Thank you. Good morning. Thank you so much, Tori, and thank you, Alex. So this is going to be a little shift in the topics from yesterday. Yesterday we discussed a lot about patient care and the details around how AI and blockchain come together for that purpose. But I'm going to flip that totally to, in order to have good care, you need a good supply chain that can actually deliver the medicines and the drugs that are required to the patients that require them. So most of my talk today is going to be about how do you manage supplier risk in the pharma supply chain, and how can AI and blockchain come together. I've got a lot of slides, so I'm going to flip certain things faster, and others I might just dwell a little bit longer. Chainyard is a blockchain consulting and advisory firm. We started our entire practice from IBM Blockchain Labs, so we understand Hyperledger Fabric very, very clearly and deeply, and from there we went on to even understand Ethereum and other technologies. So that's our claim to fame. We also have won several awards, like the Stevie Award for building a disaster management solution. We have a services practice, and now we also have another practice where we build solutions and one of our first solutions is Trust Your Supplier, which will be the topic that I will touch periodically as I go through the rest of the slides. Now, I'm the CTO of Chainyard. I supported building our practice for both our blockchain, and now I'm focused on AI, and I've been involved with more than 40-plus solutions. Many of them are POCs. Some of them went into production, and our own solution, we took it from idea all the way to production, and so we understand all the nuances in the 8 years of what it takes to make something real, how to commercialize something. My entire career, my first project was with healthcare. I began my career with Tata Memorial Cancer Hospital, and at that time I did not know what I was doing. I was essentially focused on calculating something known as ASCAR values, which was trying to figure out what is the impact of cancer on populations by age, gender, geographic location, religion. So moving forward, I continue to support certain clients on healthcare. That includes Pfizer, Medtronic, Blue Cross Blue Shield of Massachusetts right here. And during these periods, I learned a lot about what goes on in the healthcare supply chain. How does the health insurance business work? Now, fast forward to today, I live in the Research Triangle Park area, and that is a hub, the third largest hub for drug discovery and life sciences. Here are a list of companies that I've been associated with more as a private enthusiast, and I felt that these companies could have leveraged blockchain and AI more effectively if that was available during that time. For example, AVR Bio, the founder essentially found certain expired patents of compounds back in the 80s that whose side effects were studied, and he found that they could be put to new uses for solving new problems and curing other diseases. Definitely Gen AI could have helped there. Same thing with TransZyme. They have a technology called Match, which allows them to turn on and off genes to study the impact of those genes on diseases. So they have a whole chemistry of compounds that they use to help drug discovery and building new cures. I also listed CBP because I was involved in a CBP project. Now, CBP looks at every package that comes into the United States for drugs and opioids. Now, they were doing this very manually. Now, imagine if AI could be used where you study the characteristics of every package that crosses into our border, and you can document it, and so it helps the CBP to predict which packages to be opened and which ones may probably go through the customs. That was an interesting discussion we had with CBP through Deloitte, of course. I did do some projects through Deloitte. Then Siventicam is a compound CRO, contract research. They have a large compound library, can definitely benefit with AI, and so on. Now, moving forward, it is not very easy to build a blockchain solution. I mean, everything looks fantastic, right? I put a network together, I have a few subscribers, I build some smart contracts, and things work. But in reality, that is not the case. we found, and we have seen how many projects have failed, and it's very clear, like there are big names like Trade Lens that have failed, B3I. The reason is that the business model is not well understood. One has to understand what the business model is. What value are they getting to the client? How is the funding model going to be? It's not going to be always crypto-driven, right? There is a funding model to build that project. There's an incentive model for members to join this network. And then, of course, you have the other things are in terms of cost. I work with Jerry Como, IBM fellow, who is also considered father of IBM blockchain. Oftentimes, he asks the question, are you willing to pay that extra dollar because you are using blockchain to bring efficiency, or would traditional technologies suffice? So we have to ask those questions often when we build these solutions. The other kinds of things that we need to consider, obviously, how do you build a consortium? Building the consortium is not very easy. It's not like a member joins your network. You have to negotiate with them. You have to sign real legal contracts, like you will comply with the European regulations. You will comply with GDPR. You will comply with the supply chain, the Drug Supply Chain Security Act. So there are a lot of things that one has to agree when companies join the network. Then, of course, you have to trust the smart contracts. You got to trust the AI models. You got to trust the prompt engineering. You got to trust the data that goes into training the models. You have to have good quality data, diverse data, and free of bias. So all those are essential components when you challenges when you start building a solution from end to end. Now, here are a few clients that I have worked with in some form or the other. As Chainyard, we have interacted with many clients, and we see a pattern, and I have only thrown in those clients that are with where we have interacted in terms of blockchain. But the whole spectrum is very interesting. If you look at the right side, there are companies which are still having legacy systems. Like if you take Shinogi, or if you take even Blue Cross Blue Shield of here, they are having legacy systems, and they are focused on transforming their legacy applications to more modern technology. So they are behind. But if you look leftwards, there are many companies that are trying to solve interesting problems. The leftmost, we have Amway, for example, was trying to see how do you track all the ingredients that go into manufacturing nutraceuticals, because there are patients who are allergic to certain kinds of constituents. So that was one of the use cases. Other you see is Delta. Delta Airlines is focused on cold chain. So when drugs or medications are transported, they have to make sure that it meets the characteristic requirements of transporting the drug, the point they receive it, all the way to the destination. So cold chain problems. And then, of course, there are other supply chain problems as usual. There is one more interesting case that I would like to say is probably Rapid Supplier Connect. During the COVID time frame, there were a lot of fake products coming into the country. And so when Trust Your Supplier, which is our solution, along with IBM East Sterling Commerce, got together, what they started to do was to qualify suppliers in terms of the risk as well as their ability to deliver. And then combined with Sterling Commerce, they were able to secure for buyers PPEs and sanitary products that came into the country. So they were able to have trust in the supply chain system. They were also able to identify alternate suppliers. One of the biggest challenges in supply chain is if one supplier goes out of business, how do you go to another supplier? So these are examples, and you can clearly see a pattern. So track and trace is a good example. There are certain resilient supply chain, provenance, and then, of course, digital identity, decentralized identity, and verifiable credentials like Avenir and Epidemium Health have focused on, and even ColigoMed. So I would, so clearly from here you can see what kind of solutions the market expects from us. I'm going to dwell briefly into the pharma supply chain. Now, the pharma supply chain, everyone is familiar with. Obviously, you have raw materials that are procured. So the process is pretty much you onboard suppliers, and then you procure raw materials. You formulate those raw materials into products. The products are then labeled and distributed, and then finally it reaches the end customer. So there are many critical players in the pharma supply chain upstream. When I say upstream, it's about dealing with suppliers. So first thing is to identify the right suppliers, And then you also have, along the way, other participants like contract manufacturers, logistics operators, transportation. You also have labeling, you have distributors, and finally, obviously, the rest of the team there. Now, here is a very simplified view of the supply chain process. I just threw in there so that we have some context, and then you can have a look at what kind of solutions can be supported by blockchain, and what are the other solutions that AI can help. Now, technically, what you can see is that supplier onboarding is the head of the process, and from there, on the right side, you have the customer. So once the suppliers are onboarded on the left side in the upstream process, and on the downstream, you have the customers in place, then the whole thing revolves around how do you accept customer orders, or how do you process contracts, quotations, pricing. From there, how do you process orders? From orders, how do you manufacture the products? How do you then distribute the products to the end client? How do you do billing and invoicing? So the process is not any different. Of course, there are so many different regulations along the way that one has to comply with. Now, typically in this kind of situation, you have blockchain that comes into play. So on one side, you have supplier risk management, which is a clear use case that we see and which is where we focused on. But there are others like track and trace, then supplier transaction management. So all along there is a flow of orders, and then there is billing and invoicing. Most often, if you use traditional methods, there are siloed ERP systems, there are siloed invoicing processes, there are inefficiencies in the whole process, and we discovered that if you can put the whole procurement process and supply chain on the blockchain, it brings a lot more efficiency into the system. On the right side, I do have a few examples of AI. Now, AI can come and play a good role in the whole supply chain process. For example, it allows one to look at regulatory processes. You can look at you can use machine vision, for example, to improve your manufacturing process. You can use AI for documentation. There are so many different use cases that one can use Gen AI for in the supply chain area. One interesting use case that I did work with within the supply chain process was rebates. There are a ton of rebates that manufacturers give the retailers. These rebates are in the form of coupons, and these coupons are used by consumers to go to a retailer and get those discounts. But there is a whole issue around processing these coupons, because the coupons go to retailers, and the retailers can be many. How do you take that? How do you bring efficiency? How do you make sure that the dollars are properly calculated, and then the payments are made back to the retailers who have already taken that money out of their pockets? So PRGX is a company based out of Atlanta. It does a lot of processing of rebate coupons. So we did study that process, and that is a very interesting application, because in the drug business, there is a lot of coupons and rebates that are available that are given by manufacturers to patients, and the patients use them at the pharmacies, right? So this is a simpler process of showing how the drug actually gets manufactured, and so there are so many different steps in the process. In this process, one has to comply with a lot of regulations. So once again, you can see that blockchain can bring a lot of value into this whole process, right? First of all is how do I have the authenticity of this process? Let me see. And then, of course, so how do I source suppliers? How do I have track and trace? How do I have the regulations that are necessary to be applied? All those kind of use cases from an AI perspective and a blockchain perspective are all applicable to actually the drug manufacturing process. Then health insurance supply chain. It's no different than the regular supply chains. Once again, in the health insurance process, you onboard suppliers. These suppliers are providers, And you also have partners. The insurance companies essentially work with providers and partners, onboard them. They also build new products. The insurance products that they have to look at all the data available so that they can build the right insurance products, and then those insurance products are distributed directly by them or through their brokers back to the end customer. So once again, this process is no different than a standard supply chain process. Now, AI here can help in terms of new product development. How do you build new products? By looking at existing data. What kind of customized insurance products can I deliver? How can I bring efficiencies? There are so many different opportunities for one to use AI as well as blockchain in this. Now, we do work with NASCO, for example. NASCO is one of the health plan administrators, where what we do is essentially bring efficiency in the enrollment, benefits, and claims process. Because what happens is, when NASCO processes an insurance claim, the insurance, a patient can have insurance with multiple insurance providers, so they have to look at all the benefits, and they create what is known as a benefit accumulation over time, so that they can properly understand what the benefits are to any patient, and they can also properly make sure that the payments that go back to the claims or whether they go back to the patient are accounted for. So we do a lot of work for NASCO. That's an insurance example. Now, if I go here, this is listing what involves, if you see all the three processes, one thing is common. The supplier is common, and supplier onboarding process and supplier risk management is a common process across all these three. Now, in our entire analysis of the business process of supplier management, we understood a lot of details. Supplier management is a global process. Today you may have a pharmaceutical company in North America, but it sources ingredients from India, from China, and various other places. So we do want to have trust in the supplier. So you can see, and also manufacturers want a lot of compliance from the suppliers today. So for example, there are potential risks. So on one side, you can see there are financial risks that one has to understand about the supplier. There has to be climate risk. There has to be conflict mineral risk, child labor practices, sustainability practices, ESG, and so many other risks that have to be understood about the supplier. Now, obviously, it is not a one-size-fits-all. So each manufacturer has a different requirement for what type of risks are important to them. The second thing is regulation. Now, regulation, there are more than 100 regulations throughout. In our experience, we have seen there are regulations by country, regulations by region, regulations by standard bodies. So in the US, you have HIPAA and the Drug Supply Chain Security Act. I'm just focusing on pharmacy. But in addition to that, there are various other regulations throughout, like GDPR, the German Supply Chain Act, the UK Child Labor Act. So all these are regulations, and one has to know whether the supplier is complying with these regulations, because not only are the penalties high in some cases, but there can be reputational problems or even litigation problems. You also have third parties in this entire ecosystem. Like on the right side, you can see data providers or analysts. That is Moody's, Standard & Poor. We have Resilink, which looks at supply chain congestion problems. You have EcoVadis that looks at sustainability problems. You have Morningstar and PitchBook. All these provide data about evaluating a supplier's risk. So when you look at the entire supplier management, it is not as easy as we see, because there is on one end the onboarding process, and on the other end you have continuous third-party risk management. You have to constantly monitor the risks. I'm sure some of you have read about the news articles where Walmart, some of the eye drops were infected, had bacterial infection, and it was impacting the patients. There was also another news article where in Gambia, some of the cough drops that were shipped from India were causing problems in children. So all those issues are real, and the best way to manage them is to manage the supplier and the risks that can be posed by the supply chain, as well as by the supplier. That's where trust your supplier comes in. Now, how did we come up with this? We are a software company. We are just somebody who builds solutions for third parties and IT firm. Now, this idea came about because when we were doing all these blockchain solutions, there are several patterns in blockchain. And one of the patterns is data sharing. A blockchain solution will not be successful if the participants in that network do not have a common interest. If they do not have any collaborative interest, then the solution will not work. Many companies fail because they are trying to take a traditional process and box it into a blockchain, but blockchain is a collaboration sport. Whether it is an enterprise consortium-based blockchain or whether it is a public blockchain, there is collaboration. And if you cannot identify that piece, that intersection where the collaboration happens, the solution will never be successful. There are many failures that I can point out. So we pitched this idea because we were working with IBM, and we were doing a procurement project in which we modeled the purchase order, the invoice, the timesheets, the contract between the supplier and IBM, the contract between the supplier and their contractor, all on the blockchain as smart contracts. Now look at it. Instead of having a siloed version of these, the contracts were modeled right on the blockchain, and then each one of the participants in the network consumed these contracts right out of the blockchain into their ecosystems, into their ERP systems. So that brought tremendous amount of efficiency. It also improved the quality of data in the entire ecosystem. So the disputes on invoices were reduced, that only 1% of the invoices really went into dispute because of some timesheet problems. But that's a case of a collaborative supply chain process. So we pitched this idea to Bob Murphy of IBM, and the idea instantly clicked. So we said, why not try it? So that's where supplier lifecycle management was born. It is a transformative method of doing supplier management as opposed to how Ariba does it today or Coupa does it, where suppliers are on the network, qualified ones, verified continuously, and shared by all the buyers on this network. That's the whole business model. So you can see data management is a key problem of almost every buyer. Their quality of the data about their suppliers is outdated. One of the reasons they love the solution is how do you solve the data quality problem? See, if the data quality is managed by a continuous monitoring, continuously shared environment, the other is how do you, the supplier digital wallet. What is the benefit for the supplier? If the participants in the network don't see any benefit, then they are not going to participate. So we created the concept of the supplier digital wallet born out of the blockchain concept of DID and verifiable credentials. A supplier can take their verified credentials in their wallet, and they can go to a bank and present their credentials to obtain a loan. So that's the whole idea. Of course, we are not there yet. Today, the supplier can only present his credentials to get onboarded by another buyer without going through this whole 9 yards. On the other side, you also see the simplified onboarding. Onboarding is a big problem. It takes almost 6 months to onboard a supplier to start doing business, whether it is GSK or whether it is any other, Glaxos, whether it is Saudi Aramco. It takes them a long time before they can onboard a supplier because it is a very manual and intense process. So supplier onboarding is simplified. You also have risk and compliance. Because the blockchain powered by AI, and AI is now determining at the onboarding time what kind of compliance is required for different suppliers across the globe. If the supplier is based in China, what compliance requirements are required in China, and what do they require to comply with in Europe? All that just boils up, and questionnaires are driven by the blockchain smart contracts that the suppliers have to complete. So it's a very, the compliance and risk management becomes efficient, right? And then, of course, integration with the enterprise systems. We often talk about blockchain solutions as living in a silo. No, it is not. You have to have the blockchain solution as an extension of your enterprise, and over time, you have to see which processes can be eliminated, which processes can be improved, and which processes, you no longer, for example, can be more efficient done in the collaborative fashion. So there are a lot of benefits, and that is what really TYS tries to drive. Now, why I use TYS is because it is a living and operating product that demonstrates how you can bring AI, blockchain together for a supply chain problem. The architecture is very simple. I mean, if you look at it, it was based on Hyperledger Fabric. And the architecture, if you see, on the right side, you have the blockchain. On the left side, you have the user interface for persona-driven user interfaces, which means how does a buyer see this? How does a supplier see this? How does a verifier see this? How does a validator see this? And then you have the whole layer of the TYS workflows and applications in the center with its connectivity to the blockchain. On the top, we built an integration framework. Why did we build an integration framework? We didn't use a standard middleware, is because you need to have trust in the data that comes into the blockchain. So if a supplier is providing information, or if there is an information that is being provided by an ERP system, we need to know the source of truth, which means if the ERP system says this is the IP address from which the data is being delivered, then there has to be signatures to prove that the data was not tampered from origin to destination. And second, there has to be proof to prove that it was indeed delivered from the point where it was promised. So we built an integration framework based on the Oracle concept. And so you can see there is connectivity to ERP systems of the enterprises on one side with custom connectors. And you also see connections to a marketplace. So the whole system is now getting data from third parties. So we are not reinventing, we are bringing the ecosystem together. So Moody's, Resilink, EcoVadis, Rapid Ratings, all these participants, Dun & Bradstreet, they're all participating on this marketplace. They plug into the marketplace, and then they're able to receive information about a supplier, and they're able to give scores associated with their ESG, their financial stability, and various other parameters. So that's how data is coming in from a risk management perspective. The scores are coming into the system. Data is coming in from ERP systems and also from the suppliers themselves. Buyers are using this information to process it further and gather a lot of insights. We also use the blockchain effectively. You can see 3 channels at the bottom. Each channel has a specific purpose. One channel deals with the workflow. One channel is dealing with decentralized identity. And the third channel, of course, we are with the oracles. So that's kind of like the architecture of the system. We have now plugged in AI. We already do traditional analytics, but we do have AI built into the system. Now, how do you do AI? You don't just randomly see. So we have taken inputs from different participants because you have to meet the requirements of the participants in order to build AI solutions. So we experimented with all these concepts, what works, what does not work, what kind of LLM to use. Do you really need an LLM for every solution? You don't need a large language module. I've had several conversations with IBM's engineers as well as certain other participants. An LM is most sufficient in many cases because all you need is an intelligent LM that you can fine-tune and then make it available for your solution. You don't need ChatGPT, OpenAI, that size of LLMs to do your problem. You can have LMs that can be purpose-trained, and then they can all collaboratively deliver large functionality. So these are all the experimental things that we built around it, and we fed it to our. We are feeding it, I would say, to the participants of the network to see what resonates, what is important to them, like is FAQ important to them, is completing a profile of a supplier automatically through AI more important to them. So those are the things that we study, and based on that, we have a roadmap. So it is essential when you roll out AI solutions along with blockchain to have a good roadmap. So if you see our roadmap, the initial AI engines are free to use by the buyers, by the suppliers. It pre-populates a supplier's profile, publicly looks at data, brings it in, it's free service. and then the next generation of AI is to go in and source from trusted sources like the grid database of Moody's or something else, and bring that information in. So you have a trusted source, a public source, and then progressing slowly to the right side, you will see that we are now focused on risk management, which means taking third-party scores coming from the marketplace and feeding it into the system. And as you move, it is continuous monitoring, where AI now starts to look at the risks and then starts to bring attention. We call it the X-ray. And finally, supplier matchmaker. If there is a supply chain disruption, because TYS knows for each buyer, we know all the suppliers that are associated with that buyer. So we know their products, we know their suppliers, and we know what they produce. So you know the supply chain. So at any point in time, if any of the suppliers in that pool for that particular manufacturer is having a problem, we know that he is going to have a supply chain problem. So how do you detect that early and then automatically suggest alternate suppliers to go after? That's kind of the whole business model, which a lot of buyers like GSK, Vodafone, Saudi Aramco, they all see the value in it. So we do have verticals, the healthcare vertical, the telecom vertical within this TYS ecosystem. At the bottom, there are common suppliers like janitors and others. So it is a truly collaborative data sharing kind of a platform. Now, I'm going to just skip in. We are using 3 different types of AI models to experiment and see what resonates. You all have heard about RAG, and now RAG is the one where I can use my custom data and then derive insights such as chat, FAQ. RAG models are supposed to be one of the best innovations in adapting AI to your purposes. You're using your own database. You're embedding them, and then you are essentially using them for generating new insights. So we do use RAG. We studied GAN, which is Generative Adversarial Network. This is probably very useful for the use cases we saw yesterday, because GAN deals with images, and most of the time, GAN can detect fraud in images, it can generate images, it can clarify blurry images. So right now, I don't see that much of a use in the supply chain process. Maybe at some point, when you want to actually see if there is a fraud product, GAN can come into play, like detecting frauds in the products that are being shipped or whatever. Now, we do want to do this. This is supposed to be the core of what we want to do, is we want to take LMs that are small. We want to train them with custom risk data, and so we want to make them. So I call it the right out of school, and then they are now becoming a specialized student, a master's student, and finally they are ready to be employed within an enterprise. So this is the fine-tuning model. There are many techniques of fine-tuning an LM for your own internal purpose, like LoRa, low-ranking adaptation, or QLoRa, and now, of course, reflective tuning. So I just read some of the postings. So there are many techniques of tuning, and tuning is a better approach to have an LM purposefully trained to work within your environment, and then later on employ them as your employees to do work with your data. With that, I think this is the last slide, and I will open up. Let me see. So many slides going through was not bad. Yes. Right. Right.
I assume
Yes.
you have interfaces for all of the services, because just like you said with the supplier, if I'm a shipper A, and I fail, your system should already be smart enough to say, hey, here's B, C, D if A fails,
Right.
and B is the quickest one to get on board. So
Right.
in the same model, if you have interfaces for all the services, then in a sense, all of the implementations of those services are pluggable.
Right.
Does that make sense?
Yes. So we do want to get trust in the system. So you see the blockchain plays a trust anchor role here. So any interaction between a third party, all those interactions are recorded on the chain. So that's why you have the Oracle, the third channel. It records request responses and what kind of interactions happened at what point in time and what is the digital signature associated with that interaction. So we want proof of interactions between external systems and internal. Now we are extending, I think I talked about it in another session, where our AI models, the AI model lifecycle management will be on the blockchain, meaning like every model that we create, what data it was trained on, what kind of solution, and what does it provide, when was it trained, who trained it, who signed off on that model, will be recorded on the blockchain, and if any changes are done. So model lifecycle management will happen on the blockchain, including prompt lifecycle management and any agent lifecycle management. Now, when it is actually applied, then the process lifecycle management will happen where what components were touched in order to execute this workflow from start to finish, which is agents or workflows. How did they execute the whole thing?
So,
sorry. We need to keep time today, so if we could put Hui on the stage and you can kind of take this offline.
Right.
Thank you very much.
All right.